this guy literally painted Jupiter. They use it NASA has one of the biggest green screen studios in the world. Why? And if you talk to people at NASA, we've talked to many of them, and they say they don't know what the person next to them is doing. Everything's so compartmentalized.
Interesting.
They say, you stupid flat earthers have an answer for everything. They call us flat tards. I try not to call them globe tards, but, I know it's the thought that counts.
Welcome to the New Age Human Podcast, where we explore innovative ideas in science, spirituality, and alternative health to help you unlock your true potential and create positive change. If you're ready to transform your life and discover new possibilities, hit that subscribe button and never miss an episode. Now, with that said, let's get to the show. All right, let's go. We got Flat Earth Dave on the show today, and I'm going to give you a little bit of a background, just a teeny weeny bit. We're going to go into a lot of that subject matter. So David Weiss, also known as Flat Earth Dave, prominent figure in Flat Earth community. He's known for his appearance on various podcasts and YouTube channels like this one. And obviously we're going to discuss Flat Earth and those theories. Flat Earth versus globe. Welcome to the show, Dave. How's it going?
It's going great, John. Thanks for having me. It's going to be a fun conversation. I love talking to people that think we live on a spinning ball in a space vacuum. I find it fascinating. I find it unbelievable, but I also find it fascinating and fun.
So the irony of unbelievable, because you have most of my friends, it's unbelievable to think about flat Earth. But mind you, we don't have too many conversations about it. So
that's amazing. Yeah.
Right.
Real quick, when you mention flat Earth to a regular, everyday person, that's the crazy one. The crazy one is the flat Earth, right? That's crazy. And then when you start getting into the conversation, like you and I had, we met at a mutual friend's party, you start realizing that the ball belief, you don't know why you believe it. And when you start getting into that, it starts unwinding, And listen, I'm not saying I'm going to convince anyone here that the Earth is flat. I'm just going to make you think about some things, and you're going to convince yourself.
You know what? I have to share this. So I'm like preparing for this show. I told the group chat for the show, I'm like, hey, I got Dave coming on. If you're familiar with him, if you have any questions, I want some good, heavy-hitting questions to really challenge this guy. And
I love it.
The people that were the most active skewed towards flat Earth. So I'm like, wait a minute, guys. I need good questions.
That's my problem. I've done 12 to 1,300 interviews since 2021, 2020. Yeah. And it's getting harder and harder to find people that still 100% believe the Earth is a globe. I either got people that say, oh, yeah, it's definitely flat and stationary. It's obvious. And other people that says, I'm not sure. And I'm not sure is actually the best place to be, because I'm not sure what this place is. I know it's not a spinning ball in a space vacuum, okay? And so it's getting harder and harder. And just as you were pointing out there, case in point, that, the people chiming in are already there.
Yeah, exactly. So I'm like, oh, man. So, I mean, I definitely have some questions, some common arguments for the globe. I mean, there are some ones that, so I wrote out a list, and I'm like, oh, I got him. Okay. Well, what about this? Oh, I got him. And then I'm listening to your episode. Yesterday, I had a lot of driving. I think I drove for 2 hours just in general. And I'm like, all right, let me get him on one of these interviews that are most recent. And so I got the list in the back of my head, and I'm waiting for you to go over that question. And you went through maybe a handful of them, and there's so much going on in the dialogue that you just mentioned one or two things. I'm like, okay, we're going to go into that a little bit more deeper. And then one of them, you started to explain. I'm like, crap, I don't know what I'm going to ask now, because the list that I have for you started to shorten. So for anybody listening, I'm still going to go over those questions, because I'm sure you haven't reviewed it yourself. Most of us that I know of, my close network of friends, haven't gone as deep as I have in the past week, let alone Dave in the past. How long have you been doing interviews since 2020?
Well, I mean, I've been into flat Earth since 2014. so it's a decade. But I really started doing interviews in 2020.
Okay.
And, and then I picked up the pace in 2022. And here I am. Here I am. We're at, by the way, we only have 90 minutes today. I already accept your invitation to come back again.
Right. Oh, man. I guess in like the shortest way possible, because I want to get into these questions. What were you always a flat earther?
Hell no, man. We're all born. Well, I think when you're born, you're a flat earther. When you're in the delivery room, you're a flat earther. Then they they inject you and they do all sorts of stuff and they commoditize you and they do all that and then they send you to indoctrination camp and you become a globe earther before you even know what you are. And they're pushing, the globe is pushed in everything. Before you can talk, your parents have a mobile over your head with the planets, and you have NASA sheets probably and NASA pajamas, and then the NASA's on Disney. And every movie, every television show, Sesame Street, has astronauts on it. It's like, what is going on with all of this? It's dinosaurs and astronauts and, and nuclear war. All right? All of that is fake. All of it. All of it. So I wasn't until 2014. I was doing a podcast called Deep Inside the Rabbit Hole, looking into all of the deceptions, New York, Connecticut, Boston, all of those things. And people started, hey, Dave, in the third year of the podcast, people, it was a big podcast, and people started sending me stuff going, hey, have you looked into flat Earth? I was like, oh, that's funny. Delete. And, and then it come again. I'm like, you're an idiot. And then they keep posting on our wall. I'm like, you're banned. Banned for life. Banned for life. Banned for... It's getting worse and worse. More and more people are sending stuff. And I refuse. And then I was talking to a fellow researcher, Sophia Smallstorm. If you know who she is, she did 9/11 Mysteries.
That's an awesome last name.
Yeah. Well, she... incredible researcher, very smart. And we were talking for an extended phone call, a couple hours, and about some crazy, fake false flag events that were happening. And I said, it's so amazing how much deception there is in this world. And she goes, oh, David, it's worse than that. And I'm like, what? She goes, I think the Earth might be flat, right? And I'm just like, I'm like, are you freaking kidding me? Not you too. And then she was the first one that I said, all right, let me see what you're talking about, right? Because I refuse to watch a 1-minute video. It's too stupid. I don't have time for that. There's too many other things going on. So she sends me this video, and I went in not as an open researcher. I went in as, I'm going to debunk this and put this flat Earth nonsense to bed and prove the globe. And that's it. That makes sense. The Earth is obviously a globe. And for 2 weeks, I didn't sleep, man. I'm looking. And back then in 2014, YouTube would feed you. Oh, you like that? Here's another video. Here's someone else. And they'd feed you all of the good stuff, right? And again, YouTube has everything on it. YouTube is like life. There's idiots, there's geniuses, there's nonsense, there's humor, there's everything. It's like life, right? Yeah. You have to sort it out. So it's just a depository for information, and then you sort it out. So I'm going through this stuff. After 2 weeks, I'm like, there's definitely something wrong with the globe. And then I kept it quiet for, I forget, it was like a month or even 6 months. I forget the timeline. I didn't want to talk about it on the podcast because I was afraid we're just going to lose our audience. We have a huge audience. If we bring that up, I had a hard enough time bringing up, the event that happened, 11 days after the beginning of September, and I finally realized I have to bring this up. And I brought it up, and it kind of turned into a whole thing. And after about a year, the whole podcast blew up because my co-host, one of them, just couldn't handle it. And, we went 3 years and whatever. And then I started the Flat Earth podcast. And because there was no podcast out there dealing with Flat Earth. There was tons of videos on YouTube and everything. And that took off also. So, but now I just go on other people's podcasts and talk to people like you, and I don't care the size. I'll do small podcasts, medium podcasts, large podcasts. I was just on Roseanne Barr. We're almost at 400,000, between her platforms. Probably
that's
even
right.
More
You flew out for that one.
Yeah, I did. YouTube's about to hit 100,000. Rumble's about like 360,000 or something like that. And then
nice.
her audio podcast is even bigger than both of those combined. So it's reaching people. If you check out Roseanne Barr's podcast now, in the background, they have my compass. They have my I gave them a wall compass.
Oh, they're committed.
No, they love it. It's actually a beautiful a beautiful compass. Let me see if I have it here. Yeah, this right here.
Oh, okay.
It's a metal cutout. And on the flat Earth, we'll just go here, and then I'll go back to you.
Yeah.
North is at the center. If we're looking down at the flat Earth, north is at the center. East and west are circles around the magnetic center, and south is every direction away from north. Okay, that's not much different on the globe, right? East and west are circles around the North Pole.
Sure.
It makes sense? Does it make sense?
It makes sense though. Yeah.
Okay.
I'm just messing with you, but yeah.
Yeah.
That compass helps a lot. So anybody that's listening only, it's go to YouTube, but it's a circle with the north in the middle, and then all where instead of where you would normally see north, south, east, west, it's all S's. It's all south. So north in the middle, and then south is just anything away from the center, which is just an interesting way to look at it.
Every straight line is south. Isn't that interesting?
Yeah, it's just freaky. All right, I want to get into some questions.
Yes, absolutely.
So since we brought up that map, the first thing, I'm just going to go with my intuition. The first thing that pops up to my mind is my wife is from Ecuador, and so we went to the equator, Ecuador. And we went to the line in the middle.
Oh, boy.
And on one side, and they demonstrated it, right?
Yeah.
I have friends that, globe and flat. So I'm constantly exploring and questioning things. So I enjoy living in the unknown. So, we balanced an egg on a needle. On one side, she, poured the water out. It spun one way. On the other, she poured the water through like this whole thing. It spun the opposite direction. Yeah. And in the middle, it just went straight down. So how do you explain that?
Yes.
The cyclone, right? We have different storms based off of this. You have cyclones, I think, in the southern hemisphere for the globers. And do you call them globers or?
I call them. They call us flat earthers. I call them globers.
Okay, got it.
Okay.
Yeah.
I try not to call. They call us flat tards. I try not to call them globe tards. But I know it's the thought that counts. So take it how you like it.
It's just fun. Yeah.
Yeah. So the whole thing at the equator with the guys pouring the thing in the water on 20 feet on one side of the equator and the other equator is stupid. It's a trick. They're pouring the water in on one side of the drain, and then they pour it in on the other side of the drain. You could do that in your own sink. Excuse me. I did it in my I did the same thing in my sink in my kitchen without moving and made it spin left, made it spin right. It's the same trick. And that's all it is. And if you look at the one that goes down the middle, it's just a parlor trick. And they want you to believe that the earth is spinning underneath the water, which is why it's doing that. But snipers don't use Coriolis. They claim that they do. Balloons float up, and they don't use Coriolis at all.
What's Coriolis?
Coriolis is that's the effect that's making the water spin.
Got it.
That's the effect that's making the water spin. So I have an app at flatearthdave.com, and this is because it bypasses all the Google censorship. It gives you all the information. But if you click the question mark button, that's the frequently asked questions page. And you go down to where it says, where's my Coriolis button? It says Coriolis somewhere. Oh, there it is. Coriolis is right there, right? If you hit Coriolis, it has a whole bunch of videos explaining what I just showed you and showing you demonstrations of how silly the Coriolis effect is. It's amazing. One of my favorite ones is this one by my co-host, Matt Long.
What's it called?
It's called Tennis. Excuse me. Tennis proves the flat Earth never spins. Whatever. I don't see the whole name of it there, but it's hysterical. It's actually a very funny video. So that's where you can learn about it. And as far as storms spinning in opposite directions, now that's supposedly by Coriolis. But what it is on the flat Earth map, and for those of you, I'll try to describe what's going on here. The sun circles around in between the Tropic of Capricorn, which is this outer yellow line, and the Tropic of Cancer. And so the sun and the moon travel this path around. Let me speed it up so you can see. All right. And they're electromagnetic. We live in this electromagnetic world. This is a much deeper conversation. and it's pushing an electromagnetic wake, a flow, if you will. So if you put your hand or a paddle, push it through water, you get counter-rotating vortices on both sides.
Oh my God. He actually had yeah, that makes sense. I mean, I do believe in, and I've dabbled a little bit in that research with the the electromagnetic world. I love that because that's where a lot of like aircrafts and anti-gravity comes from.
And we need to talk about gravity, somewhere in this conversation, because
Let's go next. That's the next one. Let's go.
You can. So that's and here's the thing: don't believe anything I tell you here. I'm just showing you a whole bunch of stuff that you never knew to ask the questions, and I'm showing you where to find the answers. And it's up to you. Belief is the lazy man's knowing. Okay, I stole that from Crow 777 Radio. Great podcast. He says belief is the enemy of knowing. I changed it. Belief is the lazy man's knowing. Where do I live?
Connecticut.
Okay. Do you know that for a fact, or do you believe it? I could
know
live in
that
New York.
based off of you telling me.
Yes, because so you believe it. You don't know it, right?
I'd have to stalk you and go to your house.
Right.
And be
And
like,
you know
okay.
what? If you had to know everything in your life, every interaction, if you had to know everything, you would never get anywhere. It's like, like you'd have to research everything. Like you could figure out where I live. It would take you a little time. Go on Facebook, look at some pictures. Find my high school. And like in an hour, you'll be like, yeah, I'm 99.999% sure he lives in Connecticut. Perfect. No one's going to do that, right? We have to go on belief, and that's how they have us. They put a guy in a lab coat with a bow tie. He'll tell you that let's go over the horizon. That's why they disappear from the bottom up. Blah, 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 blah. And then you just believe it because that's you're told from somebody who supposedly has authority.
Yeah, and I want to add to that.
Yeah,
I agree because you would have thought, and there's videos in the past where they record people. I think it was like the 70s. They're like, oh, what do you think it's going to be like in the future where we have all this technology and whatnot? And some people thought that we were going to have all the time in the world because we're going to have all these robots, and now we have AI, and we're going to have all this extra free time to do research. And for some people, yes, but for the many, with a lot of the death grip that we have financially, socially, and just a lot of division, is getting worse and worse and worse. So it's getting increasingly more challenging to do the research. So I agree with you 100%. But there are people like yourself and myself that do some research and do our best to put it on some type of medium with the hopes that it won't get censored. And in your case, you created an app. So, there's a reason for everything. So I agree with you wholeheartedly.
And full disclosure on the app. By the way, the trolls will show up in your podcast and the comments, and they'll be like, Dave's a grifter. He's just trying to sell his app. He's trying to dumb down the world. But the app's $3, by the way. And it gives you 95% of the stuff in the app is included in the lifetime $3. But there are advanced features like messaging people, profiles, a matchmaker, a meetup maker that require an $11 a year subscription. I couldn't make it any cheaper. $11 a year.
Yeah. So you can, when you're going on a date, you can skip the flat Earth conversation.
You can listen. We have. I'll show you. There's almost we're pushing 200,000 people on the Friend Finder, and they're all smart, where they didn't stick something in their arm when they were told to. And they're all open-minded, and they're all beautiful people. So you have more in common with them once you understand what this place is than anywhere else. So where we go? You have a question? All right, gravity. So flat earthers are crazy because we think down is down for everybody. We think when we hold a plumb bob, it's the same as every other plumb bob on Earth. A plumb bob, plumb bob is a string with a weight on it.
Okay.
Right? A string with a weight. That's how they determine vertical when they're building a building. They hang a string with a little metal weight with a pointer on it, and they can get the exact vertical. But on a globe, it's not the same. We flat earthers are crazy because we think all plumb bobs are vertical, right? Globers say we're crazy because all plumb bobs go in every different direction depending on where you are, and there are no parallel lines on a globe. Globers say no two lines are parallel.
Okay. Based off of that, correct.
Yeah. So everyone's standing, people 12,000 miles away from us are standing antipodal to us. Their down is our up, and our up is their down.
Right, the old saying of digging the China type of thing.
Yeah.
When you're
We're
a kid.
spinning, right? So think about centrifugal force of spinning. We're going 1,000 miles an hour at the equator, right? So you're standing on the equator. Okay, what if you're standing halfway between the equator and the North Pole? Wouldn't that spin kind of make you tip over? Wouldn't that spin kind of make you tip over? Think about the centrifugal force of that.
Well, when you're in a car, you don't feel the car moving though. You only feel it when it
Yeah,
stops.
but you're going straight. No. When the car takes the slightest turn, you feel it.
Yeah.
Right?
Yeah.
So when you're going, whether you're going a mile an hour or 1,000 miles an hour or 1,000,000 miles an hour, going in an enclosed system in a perfectly straight line, you can make the argument that you wouldn't feel it. But take the slightest turn and you're going to feel it. The SR-71 Blackbird goes 2,300 miles per hour. It's like Mach 3.2 or something like that. And when it's going that speed, it cannot turn. It cannot turn left or right or it'll break apart. Okay? But somehow it's nosediving down at 80 stories per second to follow the curve of the Earth.
And you're saying that the natural force of gravity won't assist with that?
Right. Natural force of gravity. I mean, first, what natural force is that you're referring to? Is gravity? Gravity's not even a force, and it's actually a theory, and they can't even prove it.
Yes, there's a lot of theories right now that are being debunked, which is we're living in an exciting time. Correct.
I certainly
on there. Yeah.
So in the flat Earth world, we live in this. Everything is everything has electrostatics. You do, the air, everything. Right. The ground has a negative charge, and the sky has a positive charge. Testable, measurable, scientifically provable. The sun and the moon are the anode and the cathode. The salt water carries the current. And the land is a salt bridge. It's a giant battery. So we live in this giant battery. So, on a flat Earth, when people say, "Oh, gravity! Look, I'm just gonna drop that and jump out of a window, stupid flat earther, and test gravity." Well, you're testing buoyancy and density, but the question is, buoyancy and density sort things out, right?
Yeah.
So here, I had a thing. Where is it? This is, So here is that. Let me fix that. So here is a blimp, right? Have you looked into old world blimps yet? Oh my Lord. Old world airships. Whole nother story. This blimp is less dense than the air. The ship is less dense than the water. And the submarine is more dense than the water. But the question is, what makes everything go down? Right? What makes things, what tells it down is the down direction. And my answer is electrostatics. I'm going to show you a little scientific experiment. So here we have some leftover helium party balloons, and we tied it. We got just like a little button here we taped to the end of this wire that goes to a Van de Graaff generator, which can generate a static charge. And we're going to add a positive charge to this. And when we add it, it goes down. Why did it go down? Is it gravity got stronger, or its attraction to the negative charged Earth just got stronger? And when you discharge it, it goes up. So
that's awesome.
That's a little experiment we did there. Here is one where we put a negative charge into it. Excuse me.
Oh, what is that? That's a what's that?
We just got a tinfoil triangle here, and and it's light, and we're just putting a small negative charge into it, and you keep the charge in it, it goes up. So negative and negative, whoosh, they push away. Huh. So are we changing gravity, or are we just messing around with electrostatics? It's clearly, obviously, provably, no argument that we are messing around with electrostatics, which are somehow overpowering gravity.
Have you looked into the pyramid technology as far as that and the what do you call it? It spins like vortexes and the ley lines. And do you think that is connected to that? Because from what I understand, it's more of like an energetic flow, which is a push and a pull, energy flowing into the Earth and energy flowing out of the Earth or the plane.
Yeah. So that is a big part of it. Here is just another more real world example. This is MIT. Thing looks like a milk crate or a skid, and it has no moving parts. It's using electrostatics to fly. It's got no moving parts. Now, Scientists will say, well, it's using the ionic flow. Yeah, what about ionic flow? There's no wind coming out of that thing, right? It's pushing ions and you can't see them. Because they have to make up something to fit with the gravitational model. This is just electrostatic propulsion. The SR, not the SR, sorry, what's that triangle aircraft? That secret aircraft they talk about.
Yeah.
The TR-3B or something like that.
Exactly. Yes, I think that's what it is. Yeah.
And they talk about how it uses electrostatics for lift and propulsion. Right, so the knowledge is already out there. Glenn Beck just did had a scientist on that said that they've discovered this electrostatic propulsion in a new way that literally cars in the future won't need wheels. Glenn Beck's freaking out over this thing, right? And they're like, yeah, but it breaks the laws of physics. It certainly does if you believe in gravity.
Well, okay? It breaks the current existing laws of physics.
Well, yeah, these aren't laws. These are belief systems in a theory.
Guidelines, right?
Yeah,
guidelines and theories.
Yeah. So here's the funny thing about electrostatics, right? So NASA, not NASA, mainstream science says that electrostatics are 10 to the 36 power stronger than gravity. Can you conceive of what 10 to the 36 is?
It's a lot.
Well, a lot. That's an insult. That's an insult to the 36 power. So a trillion is, well, let's talk about how big a trillion is. 1 trillion. Now we have a number of trillion. We're at $71 trillion in debt. This is a $1 trillion deficit. Whatever. People like trillion. Okay, billion, trillion. What's the difference? How long is 1 trillion seconds?
Like 1,000 years or something like that, like something insane.
31,000 years.
That's
okay.
That's 30 times more insane.
31,000 years is 1 trillion seconds. I say this on a lot of podcasts, and people that are hearing it again, you need to hear it again and again and again because you don't understand. 31,000 years, I don't even think the Earth has been around that long. Okay, but 31,000 years, that's 10 to the 15th power. If you added 3 more zeros to that, that's 1,000 times that. Right?
It's just a lot.
We got to do that again. We're not even halfway there yet, 10 to the 36. Right? Times 1,000, times 1,000, times. You can't fathom this number. So, that's what they say. Electrostatics is 10 to the 36 power stronger than gravity. Let's pretend gravity is real. Okay? So, electrostatics is pulling this ball down 10 to the 36 times stronger than gravity. That means, and it's a weak force, right? The electrostatic force is pretty weak. That means gravity is 0. 10 to the 36 zeros, 0.36 zeros. Maybe I'll give you a 1 after that. Maybe. If it was real. That's 0. That's 0. So how can you say gravity is responsible for any of this when it's go prove your gravity. Do a scientific experiment like I just did, showing you electrostatics manipulating things going up and down. Explain to me why during electrical storms things fall at different rates. Explain to me when.
Which is interesting.
Yeah.
That will be a huge tell. But then in an electrical storm, you have a different density of air too.
Well, right. I mean, but sometimes when lightning strikes the ground, people and things right next to it go flying in the air. Did it change gravity or did it change the polarity of the Earth for a split second?
That's interesting. Yeah. Or maybe that's how, like that movie Twister, where you have cows flying around in a tornado, right? And just messing up with the electrostatics.
Electrostatics, right? Is it really the wind lifting it up, or is it the electrostatics?
Oh, that's actually, that's another aspect of it. Because it's an actual real thing, but I'm like, how does the wind pick up an animal? But I've seen it destroy stuff, and the force of it is insane, right?
Yeah.
But it does make more sense that you have it's just layered on with electrostatics. But there's sacred geometry. Are you familiar with that?
Oh, yeah.
Where you have the understanding or the theory that our solar system is based off of frequency, vibration, and that's what keeps all the planets in place. Each planet has its own geometry, and that's where all I forgot the names of it. Like, let's say, I think it's a dodecahedron, and all the vertices of the dodecahedron on like let's say like you overlay a dodecahedron onto a planet, like let's say in this theory the sphere, and the vertices that touch the landmass are the vortexes, and they found that to be true as far as that matches up. How do you explain that? I mean, like that's one theory, and it helps with understanding when you go down and you really dissect a lot of matter, right? Which is just mostly energy. You see these geometric shapes, and that also coincides with cymatics. And I'm wondering if you ever had a conversation around that stuff.
Yeah, that's a whole nother topic. That would work on a flat Earth and a globe Earth. I don't see any difference, but the flat Earth is, you can't live on a globe Earth in a space vacuum without a container. You can't contain air, without a container. Gravity's holding the air down, but I can suck air away from the ground with a straw with the weak, not even, low pressure of my lungs, but the Tor 17 vacuum of space can't pull the air off of the Earth. It's all crazy. I love the cymatics thing, but that's a whole nother show. A whole nother show of stuff.
That's when you come back.
Yeah. Why we're talking about you're just talking about tornadoes, right?
Yeah.
You ever seen a tornado in person? Well, you've seen the destruction power, right?
Yes.
And a tornado is like 300-mile-an-hour winds. 300-mile-an-hour winds, right? That's crazy, right? And what temperature is it when there's a tornado? I don't know, normal temperature. It's room temperature. We'll just call it room temperature. It's cold. Yeah. It's tornadoes usually happen in the summer, so we'll say between 60 and 80 degrees. Okay?
Okay.
So if you had a 50-mile-an-hour, 80-degree wind blowing at you, kind of feel pretty
Fahrenheit.
Cool, right? Blowing your Fahrenheit. A hurricane, a 200 and my father lived down in the islands, and they had Hurricane Hugo, 220 miles an hour. It blew almost every house off its foundation. Okay, that wasn't cement, and 220 miles an hour. That's crazy. A tornado, 300, maybe 350. It pulverizes trees. It ties metal poles in knots. Right?
Wow.
It does everything, and that's at room temperature. What would happen if you had a 600-mile-an-hour tornado, a 1,000-mile-an-hour tornado, a 10,000-mile-an-hour? You can't fathom this, just like 10 to the 36, right?
That's what they're saying that is going on in Jupiter. Like it's just
It's crazy. So this is the space shuttle, okay? Right? This thing goes over 17,000 miles an hour. It weighs 4 million pounds. The thrust coming out of here, the flames, are a little bit higher than 80 degrees Fahrenheit. And it's coming out at 20 or 30,000 miles an hour to get this thing up. Okay? These people are 11 miles away, but they want you to make it look like they're right there. And watch what happens to this fence when it takes off, okay? First, this fence right here doesn't shake.
And for anybody listening, there's a fence right next to it.
Nothing happens. Nothing happens. Everything would be obliterated. That's 20, 30,000 miles an hour superheated flames. Everything would be pulverized and vaporized. Nothing happens. I'm showing the shuttle taking off. You really got to watch the video on this.
Yeah. Highly suggest watching the video. But so, I mean, with my global thinking cap on, well, there's scientists that work at NASA. They did the math. They know the materials to build the facility and to make sure that doesn't happen. Of course, it won't happen because then it wouldn't. They went through that already.
Show me the science that that can withstand 30,000 mile an hour superheated thrust. Show me the science of a satellite that's in the thermosphere that's handling degrees of 3,000 degrees where it doesn't melt. What metal doesn't melt at 3,000 degrees, right? Show me the science of high pressure next to zero pressure without a container, right? And if you talk to people at NASA, we've talked to many of them, and they say they don't know what the person next to them is doing. Everything's so compartmentalized. And,
that part makes sense.
Yeah, and there's people at NASA that know. There's also many people at NASA that don't know. They're
do you know anybody in NASA?
we've interviewed people, and they're like, well, my job was this. I make these parts, and then they go here. And I don't ever see that. Like the guy that runs the Hubble, the head guy for Hubble, the telescope in space.
Yeah.
We had one of our guys got him on the phone, and he's said he was a research student. I think he was at the time in college, and he was talking about the pictures that the Hubble took, and the guy is talking about it, and the guy realized he never has seen the Hubble. He's only gotten data. The head guy in front of Hubble has only gotten data, right? This is the Hubble, right?
Yeah.
Looks to me like a garbage can wrapped in tinfoil, but that's a whole nother story, right? And our guy had done some research where he found some pictures from they have a telescope called Sophia, and the Sophia is mounted in the side of a 747 where it has a big hatch that opens up, and it can film things out in the sky. I don't want to say space because space is fake. And they were the same pictures that Hubble was getting. And the guy that runs Hubble didn't know this.
Huh.
He didn't know
That's
that.
actually
So
kind of sad.
The head guy for Hubble did not know what we were showing him. This isn't theory. So
Who's showing him? Like someone is beyond him telling him what to organize.
True. But they release these pictures from they. Here's the thing. Here's the beautiful thing. Whether they're stupid or they do it on purpose, because I'll call it revelation of the method. They always tell us the truth. It's whether we're smart enough to see it. They always tell us what's going on, and the question is, are we smart enough to see it, right? Here, just since we're talking about Hubble, this is a couple of years ago before the James Webb. This is the new Hubble photograph they got. Look at it real careful, right?
Okay.
And then here's the old one. It's the same photo.
Just at a different angle?
It's just the same photo. It literally, when you zoom in, it was hard to see from what I showed you. It's the same photo.
Oh, so you're saying that they zoomed in. Go back real quick.
No, it's just the same. It's just the same nonsense photo. It's just literally, it's a garbage can. It's literally a Del Monte beans wrapped in tinfoil, right, with little wheels from a balsa wood, airplane that we used to fly. Right? It's the dumbest crap ever, and people are like, "Oh man, that's a $30 billion telescope." Yeah. It's so silly, right? And then they show us, they dazzle us with images. Oh, this could never be created on a computer. This is from Hubble, looking at something light years away.
All the images of Pluto and Saturn, and the fact that they get clearer as we get, as time goes by. You think those are all computer generated? So
not even computer generated. Many of them are just painted, right? Many of them are just painted. So here is this is a new picture of Jupiter. Wow, look at that. That's. I mean, I couldn't do that by putting some watercolors in water and spinning it around, right? And people will believe anything. Like, what planet is this? Do you know?
That's Jupiter.
Is it?
I mean,
if I zoom in on it,
unless it's
Saturn.
Actually
a meadow with ducks. Okay, what I'm showing you is how easy it is to fool people. I was fooled by it too. Don't feel bad. Okay, when I saw that, I'm like, yeah, it's obviously Jupiter, obviously, right? And this is what they have at NASA. This guy literally painted Jupiter and they use it NASA has one of the biggest green screen studios in the world. Why? Right? So this is at NASA. And they have tracks for cameras that go around it. And they have fake moon and everything, right? This is the famous picture from 2014 that this is the picture of Jupiter. It's from that, right? And then in 2016, they said, we filmed the Northern Lights on Jupiter.
Photo.
We filmed the Northern. Look at this.
Yes.
Look at that. Northern
you know
Lights.
What? Yes,
okay,
that brings. That reminds me that I remember seeing photos of Jupiter, and you see the huge eye. And the eye always looked the same, and I was wondering, I'm like, how is it a storm, but then it doesn't change? And how is it? They're just recycling the same photo?
These two pictures, over 2 years apart, every cloud is exactly the same.
That's freaky.
Every cloud
obviously the same photo.
Every cloud is exactly the same. Obviously the same photo. I'm just trying to. I have but they'll be like, well, it's so big, the storm, hardly moves, and whatever.
Right.
Where is and then that way, I'll show you this real quick, and then we'll go back. This is NASA just released this recently of the moons of Jupiter. Look at this.
It's a video.
This is a video. This is from NASA.
That definitely looks like CGI.
You think? You think? Well, flat earthers say everything's fake, so you're welcome to the club. They accuse us of saying everything's fake because everything is fake, right? So this is NASA. This is whether it was over a couple days, couple hours, a couple weeks, doesn't matter. Here's the storm. It's spinning. You got counter rotating, storm tracks.
Right.
These are clouds. How is every friggin' thing the same? This was shown to us in like 1970 or 80, whatever it was. The Voyager was going by. Is it right? That just completely debunks what I showed you. They showed us the exact same images. And then think about this. The Voyager then at 60,000 miles an hour went by Pluto. Right? Pluto is so far from the sun that the sun looks like a tiny little star. How does that tiny little star light up Pluto? So bright that we can get a photo of it traveling at 60,000 miles an hour and then send that back with 1970s technologies to Earth and get this photo.
I see Pluto the dog. I see Pluto's head.
This is the actual image from NASA, and it looks like Pluto the dog. That's just a coincidence. That's pareidolia, right? We're just imagining things, right? We're just imagining things.
No, yeah, that could be coincidental.
And then recently they get this new picture of Pluto. Look at this. What the heck is that? It's not even a sphere. Like this is just. Did they have a fifth grade contest? Hey, make a planet, right?
Yeah.
Right.
Well, nowadays you see more color.
I have a question for you. Are these planets from NASA?
Now I don't trust it because the last one was a meadow. So now I'm like the bottom right. He showed me an image of like 3 different planets.
Yeah, these are actually frying pans. Okay, these are all the bottoms of frying pans.
Oh, that reminds me. I have an image. Those the street artists. They have like aluminum foil, and then they use the spray can, and they make planets.
Yeah.
Off of dabbing the aluminum foil.
It's
and I'm
so
like, wow, it's
easy.
So amazing. It looks just like it.
Check this out. Now NASA discovered a new Earth-like planet. Okay. It's amazing, but all the land is on the bottom. It's pretty cool, and here's a video of it. Or is this just a guy in his shed with a fisheye camera filming an old propane tank?
Oh, that's annoying.
Okay? I'm just saying, NASA gets $80 million a day for what?
That's the budget?
$80 million a day, every year, all day, all weekends, all holidays. $80 million a day. What do they give us? Oh, we're in space. We're doing science. On my channel, DITRH, my main YouTube channel for my short videos, for those of you that are just like, what? Flat Earth nonsense. My latest video is NASA and the Olympics. They had on the ISS, they were pretending to be in the Olympics, competing in zero gravity. Uh-huh. It is the stupidest thing you've ever seen, okay? And this is what they're doing up there. They're playing games. $80 million a day. $80 million a day.
Well, the acronym that I think is funny with NASA is never a straight answer.
Not a space agency?
No. Okay, I like that one too.
There's a whole bunch.
Okay.
Yeah.
Oh, so you have more. So you have more planets on.
No. The last thing is, this is what NASA gives us, and then this is what all of our super zoom optics give us. Hey, what are these things? I don't know. They're all named after gods. Okay. Interesting. Interesting.
And it looks like the reflection off of water when something's in the water.
Yes. Now you've seen some of that. We have one guy on TikTok. He's got great, like incredible telescopes. He's an amazing guy, and he zooms in on the moon perfectly in focus. Then he zooms past the moon. Moon goes out of focus.
Right.
And he zooms back in. Moon's in focus. He zooms before the moon. Moon's out of focus. So he's showing that he can zoom in on the moon to a focal point.
Right.
He could do the same with a planet. He could do the same with stars. But then he could zoom in on any one of them and move the camera from one to the other, and they're all in focus.
That's freaky. Okay.
Yeah, which is crazy. But when we look at stars through today's consumer optics, this is a burning ball of gas, countless trillions of miles away.
So let's get into that because you keep bringing that up, and I want to make sure we hone in on that. There's that, and I think this can also coincide with the horizon. As things go further away, they get smaller. And I think you have an answer that's similar for both, where you have the boat as it goes out to sea, and then the horizon, it disappears from the bottom up. And if it was flat, the whole body would get smaller and smaller and smaller.
Yes and no. It depends on the atmospheric conditions, right? So think of the Earth, flat or globe. It's got its layer of atmosphere. You're down here on the Earth.
Right.
When you're looking up, you're seeing through this much atmosphere. When I'm looking that way, I'm seeing through maybe 2, 3, 4 times that amount of atmosphere. When I'm looking straight across, I'm looking through infinite atmosphere. It's all atmosphere. Right?
Okay.
And
On
so
a flat
atmosphere
plane.
on a flat plane, it would be, just draw a line. There's your flat plane. Draw a line above it. That's the top of your atmosphere. And then look up, look 45 degrees, and look to the left. Right? So it's going through infinitely more. So as the sun goes farther away, you're looking through more and more atmosphere. So that atmosphere, when it has moisture in it, is magnifying it. So it's getting smaller, but it's also getting magnified. This is a beautiful place we live in. Right? Here's a pretty dry day. And the sun, like when you're watching the sunset, are you falling over backwards faster than the speed of sound? Or is that sun just moving away and taking its light with it?
You wouldn't be falling over because
if you're on a globe,
gravity.
if you're on a globe and you're watching the sun, you're falling over backwards faster than the speed of sound. You're not falling. You're spinning backwards on a ball.
Yeah, yeah.
So when you're watching a sunset, these people here are falling over backwards faster than the speed of sound, which is making the sun appear to go down. Or is that sun just going away? And look, this is the soup of the atmosphere. It becomes opaque. It becomes opaque over distance. So the sun just goes away. And sometimes it gets smaller. Sometimes it gets magnified, right? Here's the sun. Now this one is, this is one where, like, is this a lens flare? What are we seeing here? That's a whole other topic. We don't have time for it. We'll do it in the next one.
That video is like you have 2 suns in that video. And that could be something else. Yeah.
Yeah. So that's a whole nother thing. Here is just to show you perspective. Street lights on a level street, they look like they're going down. The sun, it looks like it's going down. It's just perspective. It's just perspective.
Interesting.
So here is so I set this up. This line here is level, and I'm looking at it from a celestial point of view. This is the same line. A little hard to see. That's level, but I'm looking at it from the countertop.
So this is your experiment.
This is my flat Earth kitchen. So this line is just, the sun is just going away, and it's going beyond. It's a little hard to see. There's like a piece of cardboard here. It's just, this is staying above it, but from this point of view, it just looks like it's going down and below it. This is the actual sun. It's going away, and it's going behind this atmospheric deck of opacity right there.
So the bottom, you're saying the bottom disappears first because of the atmosphere?
The bottom, this because of the atmosphere and because of land, anything like in the distance, 100 miles away, there could be a mountain that you can't see. The light coming off that mountain can't push through the atmosphere, and it just becomes opaque sky. But when the sun goes beyond it, I'm going to show you that in a second because that's a big one. How the sun sets is very, very, very important. So here, I'll show you right now. Here's perspective. How we're taught how everything from the sides go in, the top and the bottom, everything goes to a vanishing point. We're taught that in art class.
Yeah.
Okay. They also don't teach you that the back to the front gets compressed also. Right?
Huh.
The back to the front. So like if I counted 1, 2, 3, 4, 5, this is 5 spaces right here, this amount of space.
Yeah, as you get close in.
So the next 5 are tighter, the next 5 are tighter, the next 5. Right here, like from here to the end, there's probably another 50 squares, but you can't see them because they're getting compressed forward to back. So here I got a guy. This is his eye line. This mountain, we'll say it's 3,000 feet above his head, and you got the sun above the mountains. All makes sense. The sun moves away, it goes beyond the mountain. Now, is it below the horizon or just beyond the mountain?
Beyond the mountain.
Right. Now, two ways he can see it. He can float up in the air and look over the mountain and see the sun, or he can go backwards. So if we put him backwards and we move that mountain 20 miles away, the sun is right where it's supposed to be in the sky. But the mountain has lowered. It looks like it's at his eye level. It looks like it's horizon. But whether the earth is a globe or flat, this mountain is still 3,000 feet over his head. Right? If it was a globe and you wanted to count in curvature, okay, take 400 feet off of that. Okay? It's still, thousands of feet above his eye line. And if you move the sun farther away, is it below the horizon or just beyond the mountain again? It's beyond the mountain.
Yeah.
Right?
Okay.
So now we add the sky level. The sky layer. There we go. That's the word I'm looking for. You got the cloud deck, which is above the mountains.
The cloud deck.
The cloud deck.
It.
You've seen the cloud deck, right? Where the level the clouds are at. And they all merge into this line also. So here we have another line. This line is the clouds merging into the same line as the mountaintops. So the sun is above the clouds. It goes beyond this line. This line is the atmospheric deck, which is thousands of feet above the mountain, which is thousands of feet above his eyes. So this horizon, the horizontal eye zone, is not at his eye level.
Slick.
It's above his eye level. Things go beyond it.
I love how you have this whole presentation set up. You're ready. Okay, I got it.
It's Flat Earth 101, my friend.
I love it.
Flat Earth 101. Because this stuff is fascinating, but they don't teach us. They tell us something. And guess what? If you want to be a teacher, memorize and regurgitate, don't ask questions, and you can be a teacher.
Yes. And that's a whole nother show as well, as far as the history of our schooling system and how it's bought and paid for. Yeah, I that whole thing. That's why I'm open-minded, because a lot of what we are taught, especially nowadays, people are more open-minded than ever, and now's the time to ask these questions, whether you're whatever your belief structure is. That's why I really appreciate this conversation and the fact that you put so much energy and time into the explanation of it.
Right.
With the graphics, with the visuals. That's why I'm
the visuals are important. I do non-visual, audio only podcasts and in person. I just on Roseanne Barr, as I mentioned earlier, I think.
Yeah.
Check out her podcast. It's really a good one, and she's blown away.
Leave this one. Just leave this one and just go to that one.
No. When you're done, if you want to see another one, because I don't expect people to give up their ball. Nobody wants to let their ball go. Okay, right?
Especially if you're a guy.
Yeah, no one wants to let. Everyone loves. Everyone. I don't want to say it. Balls. Everyone loves balls. All right, I said it. Okay, I said it. Let me just show you another thing also, which people go, oh, I've never seen that. The Globe trolls absolutely freaked out when I presented this, because it happened several times. So this is what I call the sun fade out. Excuse me. So the sun is up in the sky, And if the Earth is rotating, it would move at the, they say 15 degrees per hour, 360, degrees around, right? It would go down, 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 and it would never stop. It would just keep on going, and it would set. That's what the globe dictates, right? But it didn't. It went down, 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 and it stopped. Super clear day, 32 degrees, no humidity. My drone's up super high, and I'm filming this. My friend's at the beach down over here. It's nighttime already. The sun already set from the bottom up 10 minutes ago, and I'm still looking at the sun. Now, whether it's in focus or not doesn't matter. It stopped, and this is super sped up. It sat here for 10 minutes. And I'm watching it going, what the hell? What the hell is going on?
Oh, that's weird.
And its light can no longer push through the atmosphere and get all the way to your eyes. So I'm just going back and forth here. It takes its light with it. It takes its light with it.
Did you research like the lens and its capacity to hold on to light and all that stuff?
Well, the Globers will say, put on a solar filter,
Yeah.
right? I'm not talking about the glare of the sun. And now, by the way, I did it again. I put on a solar filter, and it's black. There's nothing there. Landed the drone, took the solar filter off, put it back up. There's the sun. Okay? What basically they're saying, put on a solar filter and blind yourself so you can't see the important part of a sunset, which is the last part when it gets down to your apparent eye level at your horizontal eye zone.
That's freaky. Okay, so since we're on the sun topic, let's go into the eclipse. I have other ones. I definitely want to get to Antarctica. I know that some people are wanting to know about that, but let's...
One more here, just real quick.
Okay.
So on a ball, there's a physical amount of curvature, right? So you can't see my mouth because it's behind a physical curve. Zooming in isn't going to help. It's behind a physical curve. So there's limitations on a ball of how far. So here's a spot in Canigou, France. We're looking out, and out here, 175 miles away is Mount Canigou. Can't see it because the globe math says the top of that mountain should be almost a mile below the curve. Okay?
Right.
The top of the mountain should be a mile below the curve from this viewing spot. Well, you don't see me. You see the light that's bouncing off of me. I could prove it, turn off all the lights in this room, and you won't see me anymore. Right. You don't see the mountain. Globers say because it's behind the curve. We say it's because the light that's bouncing off the mountain doesn't have enough brightness to push through 175 miles of curvature. I mean, of atmosphere.
Also, the last video you showed the sun fading out. So that coincides.
Well, that's a little farther, but this is it. The sun's light can push through 175 miles, and as it goes beyond, not below, the mountain, it backlights it, and here's the mountain in its full. The top of this mountain should be over about a mile below the curve.
Based off of the curvature math.
Based off the curvature math, and the Globers say, well, actually, the sun has already set. It's refracting up. And the mountain that has no light on its backside is also reflecting up, blocking the refracted sun. Okay? If your mind didn't follow that, it's because it's stupid. All right? It's stupid. You're not stupid. It's stupid. Okay?
Yeah.
If you can't follow something, it's not because you're stupid. It's because what they're saying is stupid.
Actually, that reminds me, and don't judge.
Oh, I'm judging.
When I used to work for a cell phone company, I used to be a tech, and people would bring in their phones, and it's having this issue and that issue. And if I didn't have an answer for them, we would joke around, and we would say, oh, it's the flux capacitor stopped fluxing. And you would just throw something at somebody just to have them give up. That's why a lot of our technology, it's smart this, it's smart that, because people don't want to spend the time to process how the tech works. So it's the refraction. It would be great to look into that and understand the science, because someone spent the time to break that down.
Let me tell you,
wouldn't be surprised if it's something similar.
It's so fun to be a Glober because you can just make up stuff. So when I first looked into flat Earth, and we'll get to your question. I started seeing, I bought a super zoom camera, and I'm seeing things that are below the curve. I'm like, that's impossible. I said, the curvature formula must be wrong. So I went to the debunking sites. And on the main debunking sites, they have a curvature calculator. It says, okay, put in your elevation height, put in your view, your observation height, the how far this thing is that you want to see, how tall it is, and it'll tell you what the curvature is, how much of it should be blocked. So it's like, okay, 100 miles, I want to see something that's 2,000 feet tall, and my viewer height is 6 feet, 3 feet, whatever you got, and it says, 3,000 feet should be hidden, but I can see it, right? So it says, okay, then there's another knob. It says, it's a refraction knob. You slide it over until you can see it, and then you say, that's how much refraction there is. Okay? It's the magic refraction knob. So somebody recently just went on there and said, okay, my observer height is 10,000 feet. My observation is 24,901 miles away. That's the full circumference of the Earth. Mm-hmm. And so he slid the refraction bar until he could see an object 6 feet tall at that distance. And it told him what the refraction is to see the back of his head. Okay? And they want you to believe, just because you got a calculator that has a magic refraction slider, just because math is right, I can show you math is right, that proves a flat floor is a sphere, right? I can do math. Math is not reality. Math describes whatever you want it to describe. Right. All right, go ahead. Back to you.
Yeah. Thanks, Dave.
Sorry.
No. I felt like I was on the news. So I love it. Eclipses, right? You have the moon. I just know that this is going to be a question because we just had an eclipse recently.
Yeah.
And every so on couple of years you have another eclipse, and it casts a different shadow, and there's the eclipse track on the United States, and you had two of them crossing over, and that's a sign and all that, and there's just a lot of stuff going on. But you have the moon moving in front of the sun, and you have the eclipse. So how does that work with the flat Earth?
You have the moon going in front of the sun. Okay?
Right.
So that's a solar eclipse or a lunar eclipse?
The lunar eclipse is, I believe that's when the sun... when the moon is between the sun and the Earth, and the solar eclipse is when the Earth is between the moon and the sun or something like that, right? When you're looking at the moon or something like that. But that's okay.
Sorry to put you on the spot, but what I'm making a point is they didn't teach us to understand that stuff exactly, because there's evidence that shows you that that's not the case. This is a solar eclipse where the moon is in between the sun and the Earth. Mm-hmm. The viewer is blocking the sun. So do you see the moon? You think you see the moon, but you see what I call missing sun. Do you see the moon? I see sky. I see missing sun. I see missing sun. The sun is missing. Okay? The sun is missing. Now, is it something in front of it? How come we don't see the moon?
Because the extreme difference between light.
Yeah. Well, you can go out in the middle of nowhere on a full moon night and read a book, and the moonlight casts your shadow on the ground. And
right.
Supposedly the moonlight is because you got a full moon, and it's reflecting sunlight back to you. Okay? During a solar eclipse, if you were on the moon looking at the Earth, you have a full Earth.
Yeah.
Okay? The Earth is 6 times bigger. I would say, with all its oceans and everything more reflective, where's the Earth shine lighting up the moon? No one has ever seen the moon from when it went to new moon to zero for over 48 hours. No one has ever seen it from the space station, from anywhere. Infrared, no one has ever found the moon. No one has ever found the moon during an eclipse. Let me show you my little model, okay? And so here's an eclipse that I filmed. This was 2 eclipses ago. And there was little chemtrails in the sky, so it actually made it really easy to film it without blowing it out. And here is what I call, this is my paper towel sky, which is a rear projection of my manufactured eclipse. So let me show you how I did that. All right. This is a real eclipse filmed, and we see this. We see this lens flare, which is moving all over the place, but this one is locked into position. It's not a lens flare. What is that?
That's interesting. And for anybody listening, you have a video of like the sun, and then you have the lens flare that's moving around, bouncing around because it's you, and then you have a reverse lens. It looks like a crescent.
Yeah. So by the way, this
Next to
is
the
like
sun.
an 85-90% eclipse. This is the sun eclipse. It's just so bright it's blowing out the camera. But if I put like a filter on, you'd be able to see the eclipse is happening. It's just so bright. That's why you're not seeing it. So this is the same amount. All three of these, the lens flare, the double lens flare, whatever this is, are all equal to what we're seeing here. So here's my rear projected eclipse. Do you see what is eclipsing this sun? You don't see it. You just see
No,
the
it's
circle.
just blocked,
All
yeah.
right. So let's take a look. Here's my projector. I got the light inside this tube. I'm projecting a circle onto my paper towel sky, and I have a Snapple moon cap, coming in, eclipsing it. See it? Eclipsing it. And so there's the projection of what we see. You with me?
Yeah.
Very easy. Very easy. So then I thought, you know what? The sky, in flat Earth, many of us think that the sky is the sun and the moon and the stars that we see are kind of projected from above. We're seeing them projected into our sky screen, if you will. And there's a lot of evidence of that. Next show. All right. So I said, what if the sky's more transparent? So then I used a tissue. I used a tissue instead of a paper towel, a little thinner. Right? And I started eclipsing it. What's this right here?
Oh my God.
That's the projector behind the towel, behind the paper towel.
Oh, that's freaky.
And when you compare it to the actual eclipse,
So would the towel be the firmament?
it could be the firmament or it could just be the sky screen. I think the sun that we see is very close. Very
So
close.
you think it's like a ball moving around?
I think the sun
surface.
is a projected point of energy. I don't think it's a physical thing. But again, I'm making no claims because we can't go up there and touch it, measure it.
Right.
But it is obviously clear that it is local and close. Right? And just finishing up on eclipses, we switch over. So that's my theory on solar eclipses. Lunar eclipses, that's a whole nother story. But a lunar eclipse is when the Earth goes in between the sun and the moon and casts a shadow. Now, I want everyone to do this on a sunny day at 12 noon, whatever, sun's high in the sky. Go outside and put a basketball on the ground and look at the shadow around. You'll see a nice, crisp shadow around the basketball, almost the same, about the same size as the basketball. Now, lift it up a couple feet. You'll see a bigger, diffused shadow, and lift it up 10 feet in the air. Where'd the shadow go? Where's the shadow?
So much else depending on the angle of the...
It all just diffuses. You can't cast a shadow a mile, let alone you can't cast. Now maybe you can cast it a mile. I don't know, depending on how big it is, but it would be diffuse. The other thing is when you cast a shadow from a sphere onto another sphere, it comes in as a tight ellipse. It spreads out and then it leaves as an ellipse. A sphere onto a sphere. Now a sphere onto a flat wall, yeah, that will stay the same shape. But a sphere onto a sphere does a whole nother thing. Here's the issue, though. Forget all that. The eclipse starts when the Earth gets in between in a scissor G, straight line between. So as the Earth moves up, the eclipse starts. Make sense?
Yeah.
Right? Eclipse starts, eclipse ends. Here's the problem. There's been over 50 documented selenilian eclipses where the observer can see the sun above his right horizon and the moon above his opposite horizon, and the eclipse starts. And worse than that, the shadow on the last one came in from the top, while he could still see both above the horizon. I can see the sun's up over there, the moon's up over there, and the eclipse is coming in from the top of the moon.
So there's even a word or a phrase to describe this phenomenon. And how does a globe...
Let me tell you how they
person
explain it. Yeah.
explain it, yeah.
Well, first is they don't address it, but science does address it. Selenilian, I just learned how to spell it. I learned how to pronounce it, right? Selenilian. The scientists, they call it the impossible eclipse.
The
They
one
call
that's
it
happening.
The astronomers call it the impossible eclipse because they can't explain it. How about
this is
that?
great.
I mean,
Like, you're introducing me to new stuff that now I gotta start looking into.
well, here's the thing. If you Google flat Earth, you Google my name, you're going to get a mostly garbage because I'm on so many different shows. The algorithm doesn't know how to handle it, and you might find some good stuff. But on my website, flatearthdave.com, there's a button that says latest interviews. I encourage you go through those. Right, all my other channels with my short videos, all the just tons of videos are there. But if you really want to learn, every day on the app there's a featured video. Click the little thumbnail. Featured videos there. If you miss some, the archives there. The frequently asked questions. We have the Tataria Old World button. The Old World button, right? The Old World button.
I know some people are gonna like that. Yeah,
dude, that's gonna blow your mind. And right here, whoops. This is a new one I just added for. Have you looked into the giant trees yet?
I'm aware of it, and it's fascinating,
dude. Just watch the first button now, which I just added. It's called Hangman 1128. This guy he's just going up and showing you stuff. Like, he's showing you pieces of decaying cedar, actual decaying cedar. Then he shows you these giant rocks in the same exact thing.
Yeah.
But when he doesn't show you the scale of what he's showing you, I'm like, wait, is that a giant rock or is that a little piece of cedar? I can't tell, right?
Yeah.
Watch that stuff. And then my other favorite right here is My Lunch Break. Have you caught him yet?
No.
He does one video a week, they're 20, 30 minutes maybe, and it's about old world stuff. And he's just exposing how stupid these lies are, on how they're burning everything down, they're destroying the old world, and it's still right here in front of us, and you can't hide it. More and more is being discovered. This alone will occupy you for the rest of your life. Okay,
That's for people that are definitely looking into it. All right, let's go into Antarctica.
Yes.
There's two things. One, there's a boat race around the Arctic, around Antarctica. So if there's a boat race around Antarctica, like around the whole continent, how could it be the reverse? Because that would be the whole outer layer of the flat Earth map.
Yeah.
And then after that, if we have time, because now we're on a time crunch right now, I wanted to address the I think the 24-hour sun in Antarctica, because I know that that's a big one that people like to refer to.
Right. So, what's the circumference of Antarctica? Do you know?
Nope.
It's 10 to 13,000 miles. Right. Continent at the bottom of a ball, 10 to 13,000 miles around.
Okay.
The sailboat race. These boats are the highest tech, fastest sailboats ever. You been on a fast sailboat? Been in a sailboat race?
Not a race, no.
But these sailboats go 20, 30 miles an hour, right? That's
Max.
fast. That's fast on a sailboat, right? And in the south, there's the strongest winds in the world are in the south, not in the north. But for some reason, all of the sailing distance records are in the north, but not in the south. Okay, weird. Okay, that's because the way things are measured out at sea, you have to trust NASA and their GPS, which is the ground positioning system, if you ask me. But the circumference of the Earth is 24,901 miles around. Why am I telling you that? So last year on the Antarctic sailboat race, they listed the different legs, and from South Africa to, I think it's from Cape Town to Brazil, they said that leg of the race alone was 32,000 miles. What is the circumference of the equator?
I forgot already.
20 just under 25,000. I'll round up, 25,000.
Okay. So
How
that
is-
fits within it, though.
No. 25,000 is the biggest circle you can make around the Earth, right?
Oh, okay.
The biggest circle you can make is 25,000 miles. This leg of the race is 32,000 miles.
Oh, that's funny.
No, it's not
Okay.
funny. It's not funny at all. Okay?
It's hilarious.
It's ridiculous, right?
So you're saying they're just boating up.
This is the race.
The edge.
This is the race. So from here around to here is 32,000 miles. And then this is just another 10, 15,000, whatever. You know, this is the route that they take. We have sailors from that race that actually Today's featured video on the app is one of the sailors talking about how they use magnetic declination, how the sailboat race actually proves the Earth is flat. And so distance is measured speed over time. Speed over time. How fast you're going for how long is the distance, okay? Right. And they say, okay, we went around here, it took us a month or 90 days or whatever it took. And they find, and they say, well, the race route is, 18,000 miles or whatever I don't know how they did it because they listed the 32,000 miles, but they say your average speed was like 4 miles per hour. 4 miles per hour, right? That's because they're going faster, right? But they're telling them their average speed is 4 miles per hour. And that woke up some of the captains of those boats. They're like, wait a minute, 4 miles per hour? That doesn't make any sense. These boats are going 25 miles an hour, right? And nonstop, 24/7. And so they're lying about that. On my app in the which section is it? If you hit the question mark and you hit circumnavigation, circumnavigation right there, bam, all of the videos explaining all of that away are there. And then Antarctica and the 24-hour sun, which you're going to ask me about in a second. Tons of videos on that, on how they're faking the 24-hour sun. Funny thing is 2014, 2015, we're like, flat Earth, there's no 24-hour sun in Antarctica. There's hundreds and hundreds and hundreds of videos of it in the north, which makes sense on both globe and flat. And then all of a sudden, in like 2017, these videos started showing up. All of a sudden, somebody starts filming, and they're the fakest. Not that we're flat earthers say everything's fake, right? We prove that they're fake. Okay. We prove that they're fake. Okay? Why are you? If the Earth was a globe, there would be 0 flat earthers. Okay, 0. I'd also lose 3 Bitcoins. I offer 3 Bitcoins for 1 globe proof. Anybody that thinks I'm crazy, watch the daily video every day for 2 weeks. At the end of that, check the FAQs before you send me your nonsense, and and you'll see. Here's the thing: 99% of flat earthers become flat earthers by trying to debunk flat Earth because they thought it was stupid. Only then will you learn, because right now you're living in a belief and you don't even know why you believe it. If globe earthers understood 1/10 of what flat earthers know about their model, you would be flat earther.
Well, knowledge is potential power, and it's wisdom on what you do with that knowledge. So again, like we started the show, many people time to do the research, and that's why there's a lot of things that are being have access to each other. But yeah, to your point, it's time consuming to
it is time consuming. And the thing is, my $3 app, which I'm grifting you guys for, I'm just here, buy my app. And the thing is, I'm making it easy for you. I've dedicated my life to this, and the app isn't something cheap that's cheap to run. Get the app and just watch the videos each day. Go read the reviews on the app. Right? Even with the troll comments, right? Luckily trolls don't want to spend the $3 to leave a bad review. But a few of them do. But just go read that stuff. When this is life changing, what difference does it make? I still have to go to work on Monday. Guess what? Today's Monday. I don't have to go to work. Okay? I don't know how that happened. But I have unplugged from the Matrix. By the way, unplugging from the Matrix. This is only for people in the USA. Especially if you're a 1099 employee where you get money via 1099 or even W-2, if you're tired of funding wars with money that they're stealing from you, I have the solution, the lawful, legal solution to not have to do that anymore. You can email me at info@theflatearthpodcast.com. We do some Zoom calls every once in a while, and we show you the amazing, mind-blowing, simple, and it's not this whole sovereign citizen retracting from America. It's nothing like that. It's literally the simplest thing ever, legal, lawful, no longer have to pay, no longer funding wars, because that's what you're doing. Every dollar that comes out of your paycheck is literally funding the crazy insanity that's going on in this world. And if you want to unplug from that, info@theflatearthpodcast.com.
As I started mentioning that to you when we met, and light, so it was a short conversation, but I was able to get someone that.
Who'd you get?
Brandon Joe Williams.
Brandon, he's great.
Yeah.
I have to tell, and I think everyone should do what he's talking about. It's scary as fuck. Am I allowed to say that? Sorry. Yeah.
If he was on the show, you
had
could
him
say
on,
that.
so I can say that once. All right. It's it takes a little courage, but it's a good thing to do. He's got this thing is different. This is literally okay. You want to become rich? Invent something that
Pretty much convenient. Yeah.
like fast food. You don't have to shop. You don't have to do anything. You know what? They'll bring it to you and bring and bring it right to you. Okay, so love to find easier ways to do things. There's nothing wrong with that, but plug from feeding the beast and keep that money. I'm telling you, say only, and there you go.
Yeah, well, I'm gonna have to. No, I like that you're doing that. You mentioned a lot of really about any. Oh yeah, that's what I want to ask you. We have about
like
10 minutes.
4 minutes left.
Okay, yeah. So, is there any, what's the newest thing of what? Because you're in this and you're constantly researching. Yeah. That you're working on right now. I'm curious.
I mean, literally, there's the hundreds. If alone disproves the globe. Now, the thing is, we admit there's many things in the sky. Do we understand the sky? The only sky is everything that we see in it is a light in the sky. Stars, sun, moon. That's all we can say. We can say, well, that light moves in this direction. You know, that's interesting, but it's about that. So when you say, oh, there's my alarm. We got a couple minutes. So one of the things is, the Earth moves around, right? We're moving around the sun. What about the other planets? Do they do?
Everyone is following the sun.
Everyone is corkscrewing around the sun. That's so.
Yeah.
Right. So here we are. Scale. Right. Everybody relax. Not the scale. Right. And so here we are. We're spinning. So Polaris is up here. Right. Thing spins around Paris.
Yep.
Everything looks like it's spinning, and Polaris is the only thing that stays stationary. That's the story.
Yes.
Everything's going around the sun. So this planet, it's all of their axes point in different directions, right? This is pointing in different directions. So Polaris is not only important to us because it's our point of rotation. Right. The question I have is, why do circle Polaris? Sacred geometry patterns. Around Polaris. These are the patterns of all.
Those are the patterns for Polaris, not the sun.
No, these are all.
Yeah.
So, they're Polaris. Something to think about. To think in this 3D. There's. We're spinning and orbiting, and and we just believe.
So I'm trying to understand. So the shapes, the paths. So if you're listening only, he's showing a screen where
Remember spirographs?
it shows a geometric path that each So that's what it's called, a spiral
The
galaxy. Oh no,
thing
no, that's
as a
something
kid,
else. But
I'm
yeah,
older than
similar.
you. Go look up. It was a
I know about it. Yeah.
maybe. Why did they take it away? Because people are starting to figure stuff out.
People were eating the paint.
People. By the way, lead paint delicious. Right? Because of Wi-Fi, they want to be able to see into your house, and the lead sun.
I heard about that too. Yeah.
7,000 feet. Look, it's local. It's lighting up over the sun right there. Not 93 million miles away. 127,000 feet.
So he's showing a video
Right.
of the sun over the Earth in a video, and as it goes further away, it dissipates instead of.
From this altitude, right? The sun's just there. It's almost the same height as the balloon. I don't know. But here is the solar thing around. This is what they tell us is going on. We're 4 billion miles a year.
Yeah.
Were before. All the other stars in our inning, and some of them, and 80% of them are they're going around each other, but never once in history changed position due to parallax. Never once crossed each other. With all of these motions going on, for once have any two stars make any sense?
You
No.
cross positions,
So you
positions
see,
as colliding, or
these are stars, right? And as we're moving,
yeah,
parallax off camera,
it blocks it. Yeah.
right? Parallax makes them change, right?
Yeah.
Never once cross positions, right? Go through a rocket and tell me if any of the bees cross each, because that's what's going on above us, right?
They all. Okay.
All right. The last thing, I know there's stuff already. We don't need any new stuff, right? How fast we're orbiting the sun? 100 miles an hour. Funny number too, right? You know all the 666s. This is NASA's I think it's NASA hypersonic tube. The sound is frightening. Sound is like, I couldn't imagine standing there. It would probably kill you. 8.6 times the speed of sound. Okay. Speed. Could you fathom twice that speed? Fathom 10 times that speed? No, you can't. Like,
I mean,
10 to
this speed
you don't even see it. So you
anything
can't
faster than that is
mentally
beyond your experience almost.
What this speed, right? Believe that we're 10 times faster than that, and we're chasing the sun in a curve at the same time. 10 and 100. But when we see lakes like this is going on, and we see and right?
Gravity. Yeah.
Gravity's your God.
That's what someone's gonna say. Yeah.
Yeah, and we see, we see stuff, finds its level, right? This water is contained. The earth is not moving. Water is level. Large bodies of water. Drop of water, a raindrop. It's round. Yes. Gallon of water. What about on a space shuttle where they're always playing with water, with electronics, right? Show me a gallon of water forming a sphere. Go ahead.
So a gallon of water won't form a sphere. That's true. Because it'll just be this weird moving blob thing going and separating stuff.
There is no.
So what would happen?
Well, it would just go on G flights, where they play with water and they do all.
Yeah.
It's been all of that's been fully explained away. If again, Griff, the app.
Yikes.
On the app, if you hit the web button page. I have actually no, the frequently asked questions page. There's a ISS button. Great stuff. We didn't even get into the ISS. So much fakery on there with wires and green screens just once. And CGI, augmented reality. Just catch them once. Or are they lying? And we didn't catch them once. We caught them hundreds. Last thing, on the app, on my website, don't even get the app. Go to my website. As Crash Course, okay? And you go to and you click the Crash Course. It's also here on the app. There's some great documentaries on here. Blow your mind. They're by Sean Hibbler. Mind-blowing. Mind-blowing. That's just an intro. That'll just get you going. And we were talking about the new world. It is mind-blowing, but there's a new movie that came out. I don't know if you saw it, Old World War. Sean Hibbler.
No, where is it streaming?
It's Stu Peters, Dave.com. You'll see this banner right near the top. Click it. It's free. And get ready to have your entire life ruined. Especially if you're a history major, forget it.
This is definitely like the Matrix red pill moment right now. All these videos.
Yeah.
You have a lot to choose from when you go to his site. And
the only thing you have to remember is flatearthdave.com. You can find the app there. You can find the free videos there. You can find new old world order there. That's going to blow your mind, right? People, last thing is Eddie Bravo. I think he said when he discovered, I think it was Eddie Bravo. Or no, maybe it was Greg Reese. He goes, when I discovered flat earth, I was kind of like, I'll never have my mind blown that much again. Right?
Yeah.
That's not true, man. Old world order is more mind-blowing than flat earth, but it can only happen on a flat earth. So everything ties back to flat earth.
Yeah. A lot of good stuff here. So all the information, or at least basic information, will be in the show notes as well. If there's anything specific, just send it to me. But yeah, thanks for coming on the show. Have a good rest of your day. And yeah, thanks for taking the time and presenting and showing the visuals and really just answering those questions.
All right, man. Just all I say is don't believe me. Look farther, and nobody that ends up actually looking and that avoids the trolls ever regrets it. Other than losing family and friends for a while and not knowing how to deal with your life and
just
having a crisis and oh my God, my entire life was a waste and that people I respected they're really just regurgitating idiots. It sucks, but it's awesome at the same time.
Yeah. Watch it by yourself first so you can digest it.
And don't go running to people. Earth is flat. Learn it first. Learn it first. And I always ask people questions. Don't say Earth is flat. Say, can you help me explain this? There's a great video in the Crash Course called A Stranger's Guide to Flat Earth, 21 Questions. It's also on the app in the movie section. Watch that. It's the top 21 questions, all summarized in 3 or 4 minutes each.
You've made content for every rebuttal that I've seen so far, so it's actually very, very interesting.
They say you stupid flat earthers have an answer for everything. Yeah, because we're right. All right, John, I love you. See ya.
See ya. Thanks for listening to the New Age Human Podcast. If you're ready to take your journey to the next level and achieve even greater results, join our monthly guided meditation sessions to manage stress, recharge, and unlock your full potential. Visit newagehuman.com/monthly meditation to sign up and connect with like-minded professionals. And with that said, I'll see you out on the next episode. Hey everybody, real quick, I wanted to make sure I connect with you and request some feedback for the show because I really want to make sure I'm creating the right content for you that you're interested in and that you're going to benefit from. Tell me, what do you like about the show? What do you not like about the show that I can improve on? Is there any specific subject matter that you want me to dive into or people that you want me to speak to? Let me know. Just go to the newagehuman.com site. On the top right, there's the contact tab, or on the bottom right, there's a little mic icon to leave a voicemail. All the links to connect with me are also in the show notes. And lastly, if you want to join the Telegram channel, I will be available in the chat room from 6 to 8 a.m. on Thursday mornings, Eastern Standard Time. If you want to find me and you want to chat, I will be there. Now, with that said, Thanks again for joining today, and I will see you out on the next episode.